Good morning and hi everybody from our Kreuzwerker office in Berlin. And we are really happy to see you all here and thanks for your time. And welcome to our webinar on how to level up your Amazon OpenSearch cluster in a week. So I see like some people are still joining. So we'll wait a couple of minutes to let everybody join us. And in the meantime, so we'll start a poll, of course, just not to get you bored and so that you don't drop off immediately, because we'd like to keep you. Okay, let me launch it. Yeah, okay. So now it's launched. Yeah, so it is because we also want to know who you are, how you use OpenSearch and Elasticsearch, what is your use case, and what are your pain points, of course. So I will keep the poll open, and now we'll, in the meantime, we'll proceed like with a round of introductions. I'm Olga, and I'm a software development consultant in Kreuzwerker. I'm also a full stack developer with focus on backend technologies in Spring Boot and Java. And I also have experience with building search solutions with Elasticsearch and OpenSearch, and also integrating machine learning algorithms to improve the relevancy of search results. And here is my colleague, Guido. Guido, please.
Good morning, everyone. I'm Guido. Thanks, Olga. I've been working at Kreuzwerker for 6 years now as a software engineering consultant. I also specialized in backend technologies and, of course, building search and analytics solutions powered by Elasticsearch and OpenSearch. In these years, I led different kinds of search projects working in different domains, such as observability of cloud-native systems, developing modern search experience for marketplaces, or building business intelligence for fintech companies. So very different kind of projects. I'm really happy to be here. Yeah, see you later.
Thank you, Guido. And okay, so today we represent Kreuzwerker, which is a consultancy company. And we were founded in 2012, and we've been a dedicated AWS partner ever since. We 100% focused on AWS, and our offerings are mostly centered around migration to AWS and modernization of your tech stack. We also do a lot of cloud native development, and we also can help you with data and analytics, managed security service, cloud financial management. We have 2 offices in Germany, in Berlin and Frankfurt, and currently we are in Berlin, as I already said. And also we have an office in Warsaw and Zurich. So long story short, let's just deep dive into the actual topic. At this point, I will just hand over to my colleague Guido. Thank you, and see you later.
Thanks again, Olga. So let me actually close the poll. There we go. Thanks everybody for voting. So yeah, moving on. Today we'll be talking about a common challenge when running search and analytics workload, that is keeping costs in check. Judging also by your responses to the poll, looks like this is a challenge for some of you too. So perfect audience. Before we begin, let me explain where the title of this webinar comes from. This diagram, yeah, fancy. This diagram represents our search assessment service. which is a fast track that we started offering a couple of years ago to consult companies that are running search workloads using Elasticsearch or OpenSearch now, and want to or need to improve their solutions because poor performance, bad scalability, high cost, security issues, and so forth. This whole process is designed for speed. We target roughly 7 days end to end, and it's built around a workshop facilitated by consultants like Olga and me. And we use this short time to focus on the main pain points of the client with their workloads, and we deliver at the end an actionable remediation plan within a week. So level up your Amazon OpenSearch cluster in a week. There you go. Of course, Kreuzwerker can also support after this week. So after the remediation plan is presented and helping the client to implement it. Should that mean redesigning their data pipelines or supporting the migrations from whatever search engine they are on to managed services like Amazon OpenSearch service, for example, or comply to data protection law, or integrating generative AI or machine learning features to words that I had to mention to keep it up, and so forth. Today, we'll give you a glimpse into 2 common activities that we do in the scope of this service, and which are the 2 activities that contribute the most to cutting the Amazon OpenSearch service monthly fees, namely assessment for cost efficiency and capacity planning. So here goes the agenda. First, to make this webinar as concrete as possible, I'll introduce Mark.com, our use case for today, a leader in the MarTech sector that needs support with their costly Amazon OpenSearch service workload. If you've never heard of Mark.com, it's because there's no company with this name, I hope. But name aside, the story I'm going to share is very much real, something we really addressed. Next on the agenda, we'll get into the details of how we assessed and addressed the problems of Mark.com, and all while sharing some best practices and nuggets of information on how OpenSearch works. And finally, we'll have some time for Q&A. You should find a Q&A box in Zoom. All right, I got some thumbs up, and you can drop your questions anytime as we go, and then we will get back there at the end. All right, let me introduce you to Mark.com. As we say, the MarTech company specialized in digital marketing services for B2B. One of their most popular products is an online platform that provides a set of tools and resources to their customers. Think of online retailers or event promoters, for example, so that they can register to the platform and run marketing campaigns by purchasing ad space on the network of websites and other media that are affiliated with Mark.com. Now, to run a successful marketing campaign, our advertisers here on the left need some tools to track marketing performance KPIs, like how many clicks, impressions, and leads are generated by what ads on what media and at what time of the day. Mark.com knows that, and that's why their platform also includes some dashboards to analyze these KPIs. All right, so what problem we're trying to solve here? To answer this question, let's go back to day 1 of Mark.com, when they had only 1 customer back then who's selling bikes, of course, and wants to promote their activities by purchasing ads on e-commerces blogs about sport or some fitness influencer on social media, all in the mark.com affiliation network. Then once online users start viewing and clicking on the ads, some performance metrics like clicks and impressions are collected by the platform, processed by an analytic engine, and presented to BackTM as interactive dashboards, where their analysts can check, for example, how much their campaign is paying off over time. Here looks like pretty stable over the last 3 months. So maybe it's time to purchase some more ads, or also investigate what publishers are generating more leads so that BackTM can optimize their marketing investments. All right. Last year, mark.com made a big investment and migrated a significant part of their platform to the AWS cloud. And finally, this is the slide where we see the Amazon OpenSearch service logo. Quick heads up. Amazon OpenSearch service is a managed search and analytics engine built on top of the open source engine OpenSearch, which is a spin-off of Elasticsearch, another powerful search engine out there. The search data and the workload are distributed across units called nodes, which together form a so-called cluster. Now, Amazon OpenSearch service is designed to work well if any preparation. And thanks to that, mark.com could use this technology as their data analytics engine, despite its engineers didn't have much experience with OpenSearch. So this is the good thing of managed service, right? But like any good managed service, it comes also with a non-negligible cost. And this is where it's going to get painful soon. So let's move to day 2. A new customer registers to the platform. ConTM wants to start an aggressive campaign via mark.com to sell more green gelatos to the world. And then we have more data, more analytics, more traffic, and the load on the Amazon OpenSearch cluster increases. But as of now, it can still handle it. So no hardware or configuration changes are needed. But then day 3, another customer comes and the OpenSearch performance begins to degrade, in particular latency, so slowing the refresh rate of the analytics dashboards, say by 1 second, so eternity. However, one of the key features of Amazon OpenSearch service is that you can scale the cluster easily and with 0 downtime, both vertically, adding more resources to the nodes, and horizontally, adding new nodes to the cluster. The mark.com engineers opt, in this case, to scale out, adding a new node to the cluster, and a few minutes later, performance goes back to normal. Of course, also costs increase accordingly, since we are now renting more resources from AWS. But then more visitors start engaging with the ads published through mark.com. And of course, this is good news for the retailers, but it's bad news for the Amazon OpenSearch cluster, which is now, again, running out of resources, trying to cope up with the additional load. This time, the mark.com engineers decide to beef up the nodes with more CPU and memory rather than increasing the cluster size again, which proved not to be that helpful for that long. So here we go. Scaling up is also very easy. No downtime again. However, that also doubled the costs. And by now, I think you got the drill. As new clients and visitors joined the platform, it seemed that the hardware required for analytics was never enough. That's a common issue that we see very often. And I think that's because Amazon OpenSearch service is really easy to bootstrap and just as easy to scale regardless of your level of expertise with the technology. But as soon as the production workload hit the cluster, it seems that the only way to keep up with increasing demand is by throwing more hardware at it, which is not what the Mark.com engineers wanted, surely not what the finance team wanted. And this is when Mark.com reached out to Kreuzwerker for support, and when our search consultants kicked off the search assessment process we presented a while ago, with a specific focus on the cost efficiency pain point. So our next item on the agenda couldn't be anything else but how to assess OpenSearch for cost efficiency. But prior to that, let's get some basic notions out of the way, how this technology works. Okay, when setting up Amazon OpenSearch service, you create a domain, which is simply a cluster of nodes managed by AWS, where managed means that AWS simplifies or take entirely care of operations like provisioning, updates, patching, scaling, backups, and security. The OpenSearch domain can be deployed in a virtual private cloud, VPC, in your AWS account, so to better isolate and secure your data. But you can also make it accessible from the internet via endpoints. Okay, data is sent to OpenSearch as a JSON via REST APIs. It's a JSON, so it could model anything like application logs, user profiles, and of course, the marketing performance metrics like clicks, impressions, and leads that we care about today. And this data can come from servers, data pipelines, message queues, databases, you name it. And they can either run inside the same VPC where OpenSearch is running, or outside. Both works as long as you set up the right access policies. Next, data is indexed into the cluster, which means that is stored and made both searchable and analyzable by nodes. In one word, indexed. Under the hood, nodes are nothing but Amazon EC2 instances optimized for running OpenSearch on it. And like any EC2 instance, they can have different hardware configurations, which you choose depending on your workload requirements. Nodes can have two roles, master and data nodes, where master nodes are the ones responsible for cluster management, for example, coordinating data distribution and replication, and where data nodes are where data is actually stored and queried from. Amazon OpenSearch service provides 3 tiers for these data nodes. We have the hot tier for frequently accessed data, so for your production workload. Then we have a warm tier, which is cheaper but less performant, and is usually a good choice for data that you don't need to process that often, like old metrics. And finally, there is the cold tier that is the cheapest option, but you cannot query data directly from it. You need to restore it first, and which makes it the perfect option for long-term archival or to comply with data retention laws, like keep your audit logs for 10 years. Okay, so we index the data, time to use it. The cluster exposes another REST API for queries with a very expressive query language for searches and aggregations, which is thoroughly documented. This API can be used by either applications or services, again, running either inside or outside the VPC where the cluster is running, provided that they're granted access to the cluster itself. Okay, so much for the basics. Mark.com asked us to focus on costs. So here are the 3 factors impacting the Amazon OpenSearch service bill. First, you pay for every hour of use of every node in the cluster for every tier. Hourly rates depend on the hardware profiles of the nodes and on their number, of course. Second cost factor. Lastly, you pay for the data transferred in and out of OpenSearch, but you don't pay for the data that is exchanged across nodes or tiers within the cluster. With this cost factors in mind, here is it? Just a sec. All right, our assessment plan. First, let me get the fancy laser pointer again. We'll review the use case and validate that OpenSearch was the right technology choice. Second, we'll review the cluster architecture, focusing on the numbers and type of nodes. Then we'll check that nodes are not wasting their CPUs, memories, and resources in general. And finally, we'll review how data is indexed in the cluster, because as we will discuss later, this has a huge impact on resource demands and therefore costs. Let's begin by assessing the use case, something that we did in a remote workshop with representative executives and engineers of Mark.com at the beginning of our search assessment process. We already presented the use case at a high level a few minutes ago. Here are just some highlights and additional details. So we have big volumes of data to aggregate for marketing performance analysis. Then we have each data type, like clicks, impressions, or leads, that has a well-defined schema, which also includes a timestamp for temporal analysis, for example, to identify trends and make predictions. And finally, internal regulations at Mark.com mandated to retain data for minimum 3 years. I keeps going back here. So, okay, what did we learn? Here are some notes. It's a big data scenario, so of course, large storage requirements, but also need for a lot of memory to run aggregations and analysis. Then we have 2 to-dos, something to look further into. Here, we're working with time series and retention policies, so we should check if Mark.com is taking advantage of warm data tiers for saving storage costs. And second, since we're dealing with large amounts of structured data, we should review how we index it, looking for any opportunity to reduce storage and computational demand. All right, assessing the use case done. Let's assess the cluster architecture and try to answer some of these questions. As you can see in the central part of this diagram, the cluster has 3 dedicated master nodes and 12 hot data nodes of type R5 4x large search, which means 16 virtual CPUs, 128 giga of memory, and 1 terabyte EBS volume each. On the left, we have the clients that are reading and writing into the cluster, all running on the Mark.com's data center. So we have the analytics dashboards, of course, querying data. Then we have microservices, which are continuously indexing fresh marketing campaign data. And we have also regular roll-up jobs to compact the high granularity data into smaller indices aggregating documents by month, for example. But let's not get distracted by the components on the left of this diagram and keep our focus here on the cluster. The first thing that we can note down, there are no data tiers. So all documents are stored in hot nodes, which are the most expensive ones, regardless of how often they are accessed, which sounds like a missing opportunity for warmer tiers. What else? Remember the node usage cost factor? We already established that it depends on the number and size of nodes. So the two questions we should ask ourselves are, one, can we reduce the number of nodes, or are they just enough? And two, can we downgrade the hot nodes, or only these R5 for X large instances can support the workload? To answer these questions, the next place to look into is the resource utilization of data nodes. Amazon OpenSearch service ships with Amazon CloudWatch integrations out of the box. So we have all the metrics and dashboards that we need for monitoring the resource consumption in the cluster. We checked that and we found hot nodes had a quiet life at mark.com. As you can see, low CPU and storage utilization and memory usage normal, under control. Now, I know what you're thinking. These charts are screaming over-provisioned hardware. So why mark.com hasn't downgraded the cluster and started saving money already? That's a fair question, but it makes it sound way easier than it is. Especially when your OpenSearch setup relies on default configurations and default indexing strategies. Sure, it works, but then it's very hard to predict how the hardware will cope with your workload. And it could happen that your cluster keeps flipping between two extremes, badly under-provisioned or excessively over-provisioned. We saw this pattern with many of our clients during our search assessments, using both OpenSearch and Elasticsearch. It's a bit of trade-off for the flexibility and ease of use that you get from these tools. Anyhow, what's going on in the mark.com data nodes? Chart on the left shows a low usage of CPU in the last week, around 2-3%, a peak of 17%, so extremely low. The second chart shows the average heap usage in data nodes. Why do we care what heap we're talking about? Well, OpenSearch is nothing but a Java application, and the heap is where it caches queries and index data. So heap usage affects the node performance and stability, and it's recommended to keep it between 50% and 70% to avoid memory issues and long garbage collection poses. Anyhow, nothing we should worry about here at mark.com, since the allocated heap is dancing around here 50%. And so the lower bound of the acceptable range. Then memory-wise, all good. Finally, the last chart on the right shows that 80% almost of the total disk space was unused. So storage-wise, not good. Based on these observations, we can safely write down that the cluster storage and CPU are clearly over-provisioned. So should we recommend scaling the cluster down or scaling in, or both? I'm asking you now, let's open another poll for 20 seconds and see what you think. Bang. I hope you see the poll. Yes. Yes. Some elevator music. Thanks everybody for voting. I see the majority of you are way more resolute than I am and opted for scaling in. But, you know, I'm a consultant and 99% of our answers are, it depends. So yeah, sorry, bummer. But depends on what? To answer this question, there is one last aspect we need to assess, that is how data is indexed, and in particular, the sharding strategy. To explain why, we need to dive again into the nitty-gritty of OpenSearch and Elasticsearch, but it won't take long, I promise. So, OpenSearch 101. The basic unit of information is a JSON document. Related documents, for example, documents about clicks or impressions, are stored in collections called indices. Every index is partitioned into one or more shards, which OpenSearch then distributes across data nodes in the cluster to enable scalability, redundancy, and parallel processing. To increase data reliability, but also search speed, you can enable replicas, with each replica being a full copy of the corresponding primary shard. Now, when we store data in OpenSearch, the requests are sent to all shards that belong to the destination index. First to the primary shards and then to the replicas. So when you have two primary shards and one replica, like on this slide, indexing operations can touch 4 shards. If you have 5 primary shards and 2 replicas, then index operations can go to 15 shards. On the other hand, search are less demanding. Search operations are less demanding because every request can be routed either to a primary or a replica shard. Why am I telling you this? Because every shard involved in indexing or search operations blocks one CPU for the time it takes to process that request, which makes the number of CPUs in the cluster a limitation to the number of shards that can be actively engaged in the cluster activities. Brutally oversimplifying, the more shards you actively use, the more CPUs you need in the cluster. So how many active shards had mark.com? Let's see. We have 21 indices, each on average with 35 shards among primaries and replicas, and each shard about half a giga in size. That's way too many, way too small shards. To give you a reference, best practices for a time series analytics use case like this one is to have shards of 50 giga, 100 times bigger than what we see here. Focusing on the active indices, so the indices actively engaged by the mark.com customer activities, we had 142 shards engaged for writes and 200 for queries. And as we said, this could be a problem because many active shards means high CPU demand. But the CPU usage was around 3%, Guido. So why should I trust you saying that this could be a problem? Yeah, the thing is that we have already established that the nodes are over-provisioned for the current workload. Our goal now is to prepare the ground for a more efficient cluster setup and index design, one that could cope better with increasing workloads. Okay, looking at our assessment notes, the last to-do is about indices settings and mappings, which is the data schema, to check if they are optimized for the use case. Now, for the sake of this webinar, it's not really important to tell you what we found, but rather what we were looking for. That is literally any improvement to how fields were indexed, no matter how tiny these improvements were. Because remember, mark.com deals with big data, so a microscopic saving in the storage footprint of one document could lead to a gigantic cumulative savings at the cluster level. So we inspected the configuration of each index, noting down possible optimization in the mapping, such as recommending the most efficient data type for each field. For example, a tip that we share often: don't store identifiers as numbers, even when they are numbers, unless you need to run queries like find all the products with ID greater than 1, 2, 3, which are not common queries. In these cases, always prefer a keyword type over a numeric types because it takes much less disk and it's faster to retrieve. We also reported some improvements to the index settings. For example, the refresh rate of an index controls the time it takes for new data to become searchable. And for mark.com, it was every second. Refreshes, though, are super expensive operations in terms of CPU and memory. And you should do that every second only if you have a use case where you need real-time or near real-time analysis. Otherwise, they don't make much sense. So we could increase the rate and then lower resource demands. Other improvements were proposed, all aiming at increasing resource efficiency and then cost efficiency. You're more than welcome to drop a question about this topic in the Q&A box, but since it's a little out of the scope from this webinar, for now, let's consider the assessment concluded and wrap it up. Our focus was cost efficiency, and this is what we have to work on. It's a big data use case, so we have big memory and storage requirements. Most of this data is not used when it gets sold, but we store it anyway in the hot tier, the most expensive one. Then we're not using our nodes efficiently, and we should consider scaling the cluster down or in, or both. Then, regardless of nodes, we should decrease the attached storage right away. We're already paying for unused storage. And finally, we can optimize the index design in several ways to lower resource demands. Good. Okay. Where do we go from here? Well, we go to the one task with the highest impact on the Amazon OpenSearch service price, the two scary words, for me at least, capacity planning, which is the last stop of on our agenda before question time. Capacity planning refers to the process of estimating the number of nodes, their hardware configuration, data tiers that could best support a given use case in a cost-efficient manner. It's not an exact science, and there is no magic formula for it. It's rather an iterative process based on educated estimates, validations, and fine-tuning, and again estimates, and again validations, and so forth. Of course, before jumping into this loop, you should make sure that your indexing strategy is as optimized as possible. And about that, with mark.com, we mentioned that something already. We looked at our assessment notes and recommended some ways to reduce the resource requirements by optimizing the index mappings and settings. Also, we proposed them a new index design that could drop the number of active shards in the cluster from over 140 to less than 40 to get much leaner computational wise. Now, I believe these optimizations are worth a dedicated webinar or blog post, which incidentally, it was already the case. I'll leave the QR codes here for checking out some resources we released a while ago. Don't rush for your phone. We're going to share this slide deck later. Or do rush for your phone. Anyhow, we're thinking about covering this topic again in the future and in more details in other webinars. So yeah, appreciate if you let us know if you'd be interested to attend them. Until then, we're all set with the preparation. Let's go through the first capacity planning for mark.com together. And before you zone out during the next 5 minutes of kind of dry guidelines, let me spoiler the potential cost savings of 2 capacity planning configurations we ended up with to convince you to stay with me. Configuration A, only hot tier, 62% Amazon OpenSearch service fees reduction. And configuration B, hot and warm tier, 72% savings. To put these percentages in perspective, we're talking about money savings in the 6-figure range for mark.com. So, buckle up. This is our recommended workflow for capacity planning for hot nodes. Again, no exact science, only experience and best practices, really. Let me share some. We start by selecting the most appropriate EC2 instance family for our nodes. Amazon OpenSearch service offers 4 family of hot data nodes for production workloads, which are general purpose, compute optimized, storage optimized, and memory optimized. Mark.com chose the memory optimized, the R star here, which was a good choice since our use case is mostly memory bound. So we kept the family and estimated the minimum storage requirements for the cluster to have a feeling about the size. And the important questions here are: how much data is indexed every day? For how many days do you need to retain the data? And how many replicas do you need? And this for each index. So once you answer each of these questions, you can use the formulas here to patch all this information together and come up with a raw estimate of the storage requirements, which also accounts for some OpenSearch storage overhead for managing the indices and the cluster itself. Yeah, sure. You should always account for some growth in unexpected growth in your storage requirements. Moving on, we said several times how CPU demand is impacted by the number of active shards in the cluster, but how much? This is how much for a first estimate. This is a best practice by AWS, which says to allocate 1.5 virtual CPU per active shard. And this will help us in the selection of the instance type, since each comes with a different number of processors, right? Earlier, we said that we lowered the number of active shards from over 140 to less than 40, which means, now that we have this formula, that we lowered the worst case estimate for compute demand from 210 virtual CPUs to 60. So now we can target much cheaper instance types. We use this estimate for CPU. We use the one for storage to now identify some configurations of numbers of nodes and instance type. And we do that the hard way. So we go to the AWS online docs, we check the specs of all the available instance types for Amazon OpenSearch, which comes with their hardware specs and along with their prices for each region. For example, imagine we estimated 8 virtual CPUs needed in the cluster for Mark.com. Should we go for 4 large instances, or 2x large, or a single 2x large? Which one is better? Again, it depends. I won't ask you again. And this is not just math. That's why benchmarking the validation step was so critical for capacity planning. But before starting running experiments on all the possible configurations, there are several best practices that can help you identifying what configurations to test first. For example, always choose instances with Graviton processors, as they are the most efficient, sustainable, and usually the cheapest one. Then take scalability costs into account. For example, if you plan to scale out your cluster, you will have more flexibility if your instances are not too big, since the cost increase will be smaller. Then consider requirements at the cluster level, like availability, which impacts the cluster size, or at the node level, like heap and memory expected usage, which impacts the instance type. Now, if it sounds complicated, it's because it is complicated. But yeah, that's where Kreuzwerker can help, right? Yeah. Did we help Mark.com? To the numbers. Okay, this is where we started, an expensive Amazon OpenSearch service domain that wasn't scaling well with the workload, if not by adding more hardware. We had 12 underused 4x large instances and less than a quarter of disk in use. With the remediations proposed to increase the resource efficiency, we could outline an iterative plan to explore less expensive setups. First, decrease the cluster size by removing 3 hot nodes, just like that. And this alone leads to a reduction of the monthly fees by 25% with no risks. 25%, we're already talking about tens of thousands of dollars per year. From here, we can run benchmarking experiments for 2 cheaper cluster configurations identified during the capacity planning process that are 9 data nodes of type i3 2x large, optimized for indexing throughput, with a potential cost saving of 37%, almost 50, and 9 data nodes of type R5 2x large, which are a bit tighter on resources than the other, but with a potential cost saving around 58%, more than $100K per year, which is already pretty good, but we could recommend much more than that to reduce costs. This we mentioned already. So Graviton instances were not released yet back when we met Mark.com, or we would have recommended our R6J to X large nodes, which would have reduced the monthly fees overall by 62%. Then we recommended changing the pricing model of all master nodes and of a subset of data nodes from on-demand to reserved instance to get significant discounts in return for committing to capacity reservation for 1 year. How much discount? 12% than this configuration. And finally, we also discussed how to introduce a warm data tier into the architecture, reducing the number of hot nodes and storing all data in cheaper hardware. So further savings of 29%. All in all, these 3 additional proposals could reduce the original Amazon OpenSearch service by over 3/4, 77%. And that's it. So the search assessment with Mark.com ended with one last meeting where we walked them through the final report and all the remediations to cut their Amazon OpenSearch service costs. We also presented other improvement opportunities that were discovered along the way. For example, we identified ways to improve security and provided infrastructure as code to simplify their benchmarking process for capacity planning. Okay, so this is where the search assessment week and also this presentation and where other opportunities begin. So if anything we have said today resonated with you, if you have an OpenSearch or Elasticsearch workload you're fighting with, or you're with Solar or a Splunk solution that you want to run away from and you need some expert support for doing that, reach out to us. Later, I'm going to remind you how. But first, oh gosh, it took very long today. I'm sorry. Thanks for staying with us. Any questions? Olga, with you. Jeremy?
Yes, thank you, Guido, for this impressive deep dive on the cost reduction strategy of Amazon OpenSearch. And thank you all for staying with us for the last hour. And we have some questions from the audience.
Good.
Yes, so the first question is, the webinar is actually about Amazon OpenSearch service. And how much would your recommendations change if you have a self-managed OpenSearch or Elasticsearch?
Yeah, good point. Let me see if I can go back. So Amazon OpenSearch service is managed, right? And you have a preset of potential configurations for your hardware. So you're limited by this preset of configuration. If you would have a self-managed cluster, OpenSearch or Elasticsearch, then you would have more leverage. You would have more freedom about, I don't know, how many CPUs, how much memory do you want to add in the cluster, and other hardware related topics, for example. Yeah.
Yes, thank you. I think that's a very good point. And also, if I can add from my perspective as well. So I would say you can also, if it's self-managed, you can specify roles. For example, you can also say, okay, so this would be like just a data node. That would be like a node dedicated to machine learning. So basically, you just have more flexibility, right? So you have more freedom.
Absolutely, yeah. And then you would you can have for each of these specialized nodes a different hardware setup. So machine learning, you would have a ton more CPU, for example.
Yeah, true. So
yeah, thanks for the question.
Yeah, thank you. There was another question from the audience asking, did you evaluate OpenSearch serverless?
Not not with production workloads, more with kind of POC setup. Yeah, I'm still a bit conflictual about it. I think it really depends on what is your specific use case. I think that it will really shine for those use cases where you have a lot of unpredictable workload in the cluster, because then you would have this Amazon OpenSearch serverless to automatically level the number of resources to the actual need. But then there are many other things that are really not that convincing for now, like the name serverless. For example, you cannot really scale down to zero if there is no workload at all. And I think it is a very interesting option, but I don't think yet that applies to all use cases. By the way, we wrote a blog post about that as well. Another plug. I'm sorry.
Thank you. Thank you. So next question, you mentioned that index lifecycle policies can make indices more efficient. How exactly?
Yeah, sure. Yeah, right. It was here. In order to leverage on warmer tiers and to apply some other tricks for saving storage, you can define automated policies that will kick in based on some conditions that you define. Conditions like a certain number of days that pass, or a certain size for your indices, or a certain number of documents. And then with this policy, you can transition the state of that index from the current, let's call it hot state, to let's call it warmer state. Because, for example, you know that you don't need as many replicas as you needed for the hot one, or because you can move it to a warm node, and you can also apply other kind of optimizations, like making the index read-only as it moves to warmer states, or to merge all the segments. But, well, there are several tricks that you can apply to an index based on the particular moment of its life cycle. And you can leverage on these tricks to further reduce resource utilization.
Yeah. Thank you so much. I hope it answers the question. If not, we have like more questions, so please write in the chat. And we have 2 more questions, and I hope we still have like about 5 minutes to answer. Yes. So one question would be, how did you evaluate machine learning plugin for OpenSearch, or did you evaluate it at all? Yeah,
no. Too bad. No, not really. With Elasticsearch, yes. But We will do that. And definitely you will hear about our experience with it. I mean, unless who made the question also meant some services like anomaly detection that are also machine learning powered in Amazon OpenSearch. But these are services that are provided out of the box from the service, like to monitor possible outliers in the behavior of the systems that are monitoring, for example, in the observability use case. But if the question was about custom machine learning model applied to your own data with the Amazon OpenSearch service, not yet.
Okay. Thank you. And the last question would be, do you have any recommendations for benchmarking a cluster?
Yeah, definitely the go-to tool would be Elastic Rally. It's an OpenSearch tool developed and maintained by the people behind Elasticsearch. There is really little time to say more about that, but as for the tool, that is the reference I would share. And yeah, this is really benchmarking clusters is worth a dedicated webinar, really. So go check Rally and the blog post that we wrote about it.